10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good day. Today we will discuss the heat transfer. Heat transfer is the transfer of heat between one body to another. In this chapter, we consider the rate of temperature of bodies with two different temperatures. Suppose you are boiling hot water to make a hot coffee or a cup of tea, or you are trying to build an energy-efficient building. So we need to know how quickly or slowly the heat is transferred. In this chapter, we consider the three mechanisms of heat transfer: the conduction, the convection, and the radiation. The conduction occurs within a body or two different bodies with two different temperatures. For example, if you place one end of a metal rod in the flame and you hold the other end, the end that you are holding is getting hotter and hotter, even though it is not directly in contact with the flame. Heat reaches the cooler end by conduction. Conduction of heat occurs within one body to another in different temperatures, and the direction of the heat flows is always at the higher temperature of point. It shows a rod material with cross-sectional area, which is A, and the length, which is L. The left side of the rod is always at the higher temperature, and which is T sub 2, and the right side is at the lower temperature, which is T sub 1. The heat flow is always from the left side to the right side, and we assume that there is an insulating material in these two sides of the rod, so there is no heat occurs within the side of the rod. When a quantity of heat, change in quantity, is transferred in change in time, the rate of heat flow is always at the change in quantity over change in time. We call this rate the heat current, and it is denoted by H. So it will become the H is equal to change in quantity over change in time. The experiment shows that the heat current is through the rod is proportional to the cross-sectional area A and proportional to the difference between T sub 2 minus T sub 1 and inversely proportional to the length. So it will become the change in quantity over change in time is equal to the H, and is equal to the K, A, T sub 2 minus T sub 1 over L. The quantity T sub 2 minus T sub 1 over L is the temperature difference per unit length, and it is called the temperature gradient. So the numerical value of the K depends on the material of the rod that it will use.
For example, a styrofoam box used to keep drinks cold at a picnic has a total wall area, including the lid, of 0.80 square meter and a wall thickness of 2.0 centimeter. It is filled with ice and cans of orange soda at 0 degrees Celsius. What is the rate of heat flow into the box if the outside temperature is 30 degrees Celsius? How much ice melts in one day? The solution is, we assume that the total heat flow is approximately the same as it would be through a flat slab of area 0.80 square meter and thickness 2.0 centimeter equals 0.020 meter. We find Kelvin from the example. The heat current is
In conduction, energy is transferred by molecular vibrations or electron motion, while in contrast, the convection is the transfer of heat of a fluid from one place to another. There is two types of convection: the free convection or the natural convection or the forced convection. The forced convection is circulated by a pump or a machine that the water will flow, while in free convection, there is the differences between thermal expansion. Convective heat transfer is a very complex process and there is no one simple equation to describe it. Convective heat transfer between a surface of one temperature and two different temperatures depends on the shape of orientation of the surface and the process properties of the fluid and the nature of the fluid that flows. Its dependence on the temperature differences change in time between the surface and the main body of the fluid is not direct proportion. In air, the rate of convective heat transfer is approximately proportional to change in time raised to 5/4. A rough approximate formula for the heat current H is convective heat transfer. Its H is equal to HA times change in time raised.
For example, the air inside a warm room is at 25 degrees Celsius and the outside air is at negative 15 degrees Celsius. How much heat is transferred through 1.00 square meter of a glass window pane with a thermal conductivity of 0.80 joules per meter per second times degrees Celsius and a thickness of 2.00 millimeter if H equals 2.0 with meter square times degrees Celsius. The solution
Capital H is heat current, small h constant, A is surface area, T is time. So the solution is capital H equals small h times A times change in time raised to 5/4. So substitute 2.01 meter raised to negative 2 times Celsius degree raised to negative 5/4 times 1.00 meter raised to 2 times 20 Celsius degree raised to 5/4. So cancel the meter raised to 2, then Celsius raised to 5/4. So the answer is 85 watts.
Heat transfer by radiation depends on the electromagnetic waves which is present, such as the visible light, the infrared, and the electromagnetic waves. Experimental studies show that the rate of radiation of energy from a surface is proportional to the surface area, which is A. It also depends on the nature of surface. Its dependence is described by a quantity of emissivity. Emissivity is the transformation of the ratio of rate of radiation from a particular surface to an equal area of ideal radiating surface at the same temperature. The heat current H is equal to the change in quantity times the change in time due to the radiation of the surface area A, with emissivity E at absolute temperature T can be expressed as the H is equal to A times T times O raised to T times raised to 4, where 0 is the fundamental physical constant called the Boltzmann constant. This is relation for the so-called second Boltzmann law, which is for the honor its late 19th century discoverers of this nation.
example of problem solving in radiation. A thin square steel plate, 10 cm on a side, is heated. A blacksmith forged to a temperature of 800 degrees Celsius. If the emissivity is unity, what is the total rate of radiation of energy? The solution is the total surface area, including both sides, is 2 times 0.10 square meter equals 0.020 meters square. The temperature in this problem must be absolute Kelvin temperature. 800 degrees Celsius equals 1073 Kelvin.